Hey guys, it's Mr. C here, and in this video I'd like to show you how to graph the rational function r of x equals 6 over x squared minus x minus 6. We're going to do this in an analytical way, mixed in with some shortcuts. So without further ado, let's go ahead and start with step 1, which is to factor both the numerator and denominator if possible. Of course, there's really nothing much to do with the numerator, so we'll just leave that as is. But our denominator certainly factors as x minus 3 times x plus 2. Now, what you want to check right away is whether or not the 6 would cancel out any of the factors in the denominator. Now, obviously, the answer to that would be no, nothing's going to cancel out. In other words, this rational function does not reduce or simplify. For that reason, we go down to our little laundry list of items here. Where it says whole, you can simply put none. Alright, so there won't be an open circle in the graph. What we want to do next is investigate where the vertical asymptotes of this rational function would be at, if it has any. Of course, this one certainly will have vertical asymptotes, and here's how you'd find them. We'll put VAs, make a little workspace here, and the shortcut to find the VAs, or vertical asymptotes, is to take your denominator and set it equal to 0 and solve for x. So here's our denominator, x minus 3 times x plus 2. We'll set that equal to 0. And you then want to use the zero product property to set x minus 3 equal to 0 and x plus 2 equal to 0. And we get two vertical asymptotes. One will cross the x-axis at positive 3. The other will cross the x-axis at negative 2. So in our list here where it says VA, let's go ahead and write x equals, and I'll go in order, negative 2 and x equals positive 3. As mentioned in class, what this gives way to is the domain of this rational function, where the solutions to the denominator equals 0, they give us the vertical asymptotes, which is good for a graphing standpoint. However, for a domain standpoint, we actually don't want to be plugging these x values into the rational function because they produce division by 0. So in short, once you have the vertical asymptotes ironed out, you can go ahead and start to construct your domain, which I'll write in set notation as the set of all x such that x cannot equal negative 2 and x cannot equal positive 3. Alright, well, now let's move on to investigate the horizontal asymptote of this graph, if it has any. Make a little workspace HA. And remember, the way to figure out the equation for the horizontal asymptote, if it has one, is to compare the degree of the numerator and denominator. Now, with the numerator being 6, you can imagine this as 6 multiplied to x to the power of 0, in which case the degree of the numerator would equal 0. And actually, let me go ahead and write it up here, 6 times x to the 0. So the degree equals 0 for the top. Just kind of axe this out a little bit. Alright, there we go. Okay, so if you look at the denominator, we have a polynomial of degree 2. Alright, so I wanted to use the original version of the function because it's easier to tell what the degree would be. So anyway, notice that the degree of the numerator is less than the degree of the denominator. So this would actually be a case 1 situation. Okay, by case 1 I'm referring to the cases from the previous section, which says that if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote by default is going to be y equals 0, which of course is the x-axis. Alright, so down in our little laundry list here where it says HA, go ahead and put y equals 0. Now, because we have a horizontal asymptote, or more properly, since we're in a case 1 situation, we're not in a case 3 situation, so therefore we won't have an oblique asymptote. So where it says OA for oblique, we can go ahead and just put none. Alright, I'm going to come back up here because I want to investigate any x-intercepts of the graph. So another workspace coming here, x-ints. And the shortcut for finding the x-intercepts is to set the numerator equal to 0. Well, you'll notice something funky about setting this equation up. In order to say that the numerator is equal to 0 is really saying that 6 is equal to 0, which obviously that's not true. So what does this mean in terms of the graph? It just means that there aren't going to be any x-intercepts. So we can just say none. And in our little laundry list here, where it says x-int for the x-intercepts, there actually won't be any. Last but not least, let's see if we can determine the y-intercept. So a little workspace for that. And what you want to do to find any y-intercept for a function is plug 0 into the function. So it's going to be r of 0. And of course, on top, we just have 6. And on bottom, x squared minus x would simply be 0 minus 0, but then we'll be left over with negative 6 in the denominator. So 6 over negative 6, which of course reduces to negative 1. So our y-intercept is at 0, negative 1. Alright, so now that we have all this information, let's go ahead and translate it into the coordinate plane to the right. We'll first start out by sketching out the vertical asymptotes. So one vertical asymptote is going to cross the x-axis at negative 2. The other vertical asymptote is going to cross the x-axis at positive 3. We have a horizontal asymptote, which is going to go along the x-axis. All right, y equals 0 is the equation for that. We don't have any x-intercepts, but we do have a y-intercept at 0, negative 1. And that's about the most we can get from the information on the left. So what you would want to do next is refer to your graphing calculator to infer the different pieces of the graph of this rational function. When you go ahead and enter this into the y equals menu, in particular in y1, you want to make sure that the numerator and denominator are surrounded by parentheses. So we'll put 6 in parentheses, and that's how the fraction bar is going to look in the graphing calculator. And as for the denominator, let's use the original function version of the function's denominator. So it's going to be x squared minus x minus 6. Alright, so when you enter this into your graphing calculator and press zoom 6, or for my TI-83 graphing calculator folks, you'd want to do zoom option 4. Here's what the rest of the graph will look like. There's going to be 3 parts to it. There's going to be a branch trapped between these two asymptotes. It's going to start out along and above the horizontal asymptote and just turn up sharply to positive infinity while getting closer and closer to this vertical asymptote on the left. There's a middle piece too, and I'm going to try my best to sketch this out as accurate as possible. My screen's pretty slippery, and okay, I'm happy with that. But here's the second piece that's trapped between the two vertical asymptotes. Now, of course, based on our algebra, it should cross the y-axis at 0, negative 1, so you obviously want to make sure that the graph crosses at that point. And then the third and final piece is trapped between these two asymptotes. So I'm going to start towards the top and on the right of the vertical asymptote of x equals 3 and hook my way down to the x-axis and just kind of bow it out to the right. And that would be the sketch of the rational function r of x equals 6 over x squared minus x minus 6. Alright, I hope you found this video helpful. Of course, if you have any questions, feel free to contact me. Otherwise, thanks so much for watching.